When we had mentioned some assumptions that need to be made in this subtopic. So assumption number 1 was the fluid is flowing steadily. 2 is that the fluid is non-viscous. Number 3 was incompressible. The fluid is non-compressible. There were 2 terms that we came up with. One was the mass flux. Number 2 was the volume flux. Was the volume flask. Was the volume flux. We say volume flux from our discussions. We were saying it was equal to the area of the cross sections. We can take it x, Vx. We need to throw our pipe. Then this is region. We are taking this to be region x, and the distance between the two was dx. Then here we were taking this to be region W, and the distance between that was that. Now the fluids flowing at the speed of VW, the area of these cross sections was AW. Now the liquids flowing in that direction, the area of this cross section, or you are calling it AX, and then this the flowing fluids. The flowing fluids is Vx. So that was that. That is what we did. And we say volume flux at this section X is that. The volume flux at section W, this was section X, is going to be equal to AW VW. And then if that is true, then there was also something else we talk about, that was the mass flux. And we say mass flux was equal to the density multiplied by the area multiplied by the velocity multiplied by the area multiplied by the distance. So we were saying the density this time is that from here we say multiplied by the volume flux. So the mass flux is going to be equal to that multiplied by the V flux. Now, based on that knowledge, if this is true, if assumption is made, and then we say since the fluid is incompressible, then the mass, then we say the mass of the fluids, and the mass of the fluids entering region X is equal to the fluids leaving region W within the same period. So, i.e., the mass is conserved. conserved. Now, so we are so all this statement, what we are saying the mass flux is equals to mass flux at x is equal to the mass flux at theta value. And then based on this, we were saying the mass flux is equal to density times the area times the velocity. Then we can say at this region we say the density multiplied by the area at theta value x, and then multiplied by the velocity x equals to density this area theta value phi x. Since this and this are common, then we can have ax phi x is equals to a theta value phi x, and that is known as, so this equation actually, hence this is called equations of continuity. Equations of continuity. So a x phi x or a w phi x is also known as, is also called flow rate, and is constant. So we can say area multiplied by velocity is equals to constant, i.e. a multiplied by phi is equal to k. So a phi is equal to k. That is the equations of the continuity. The product of area multiplied by the velocity is constant. It means at region x, flowing, that is the fluid flowing or entering in at region x is equal to the mass flux of the liquids leaving regions. So this equation is true if this one has been put into considerations. So these are the formulas. So area multiplied by velocity is equal to constant, and that one is known as the equations of continuity, or you call it the flow rate. So after that we can say thank you until next time.